All right, so let's take a look at this example. Um, see which of the following statements are true if A, B, C, D, and E are arranged in that order, like in decreasing order. Um, so let's take a look at the first one. Is this one true? You can type yes or no in the chat, or true or false. This is just the property we were talking about earlier. So this one is true. And same with this one, it's just subtracting D, which means A is still greater than or equal to B. So this one is true. Anyone have an idea for number 3? Okay, Richard has all the answers. All right, since D is greater than or equal to E, this one is also still true. Oh wait, 3 is false. Oh, sorry. All right, sorry about that. Yeah, so like Anant said, if you plug in the numbers, you get 6 minus -1 is greater than B, which is 4 minus -4, which is 7 greater than or equal to 8, which is not true. So if you subtract two inequalities, the subtraction actually doesn't work. My bad. Okay, and then let's take a look at number 4 now. Since we're multiplying by a constant that is non-negative, C equals 2. This one is true. But for number 5, D equals -1. So if we do division, it would actually flip the sign. And that means that A divided by D is not actually greater than or equal to B divided by D. So this one is false. But for number 6, E squared is 16, positive 16. So in that case, it would be true since we're now dividing by a positive number. So for number 7, so we start with A is greater than or equal to B, and then since D is greater than or equal to E, and we're adding the two inequalities, it would be true as well. Okay, and then for number 8, we're dividing by an inequality, and that wasn't one of the rules that we had. So if you just want to double check and plug the stuff in, you can see that it doesn't actually work out to the right answer since we get -6 is greater than, I believe, -1, which is false. And same thing for um, AD is greater than or equal to BE. Since the numbers are since the numbers are negative, the statement is not true. So this one is also false. Okay. So let's take a look at this checkpoint. Um, we'll come back in about a minute to talk about it. Oh, and this one is a proof, so you don't have to type anything in the chat. You can just try it for yourself and see what happens. Okay. Uh, is anyone able to show it? Okay, so let's take a look at how to solve this one. Um, so we start with a is greater than or equal to b and c is greater than or equal to d, and we're trying to show that um, AC plus BD is greater than or equal to AD plus BC. So since it's all real numbers, A, B, C, and D, we can't use theorem 1.3 because we don't know whether B and C are non-negative. Um, However, on the other hand, we could solve this with using a few cases. So first, if let's assume that B and C are um, non-negative. In that case, the theorem 1.3 does hold, and we do have that AC plus okay. Oh wait, sorry. Let's look at Divier's method instead. Okay, sorry about that. My Wi-Fi cut out. Okay. So wait, let me start recording again. Okay. That is not right. Okay, so A minus B is greater than equal to 0, and C minus D is greater than equal to 0. Or, but actually we'll only look at the first one. So if we multiply both sides by C, then AC minus BC is greater than equal to 0. And for this one, if we multiply both sides by B, we have BC minus BD is greater than equal to 0. So if we combine the two together, we get that AC plus BD is greater than equal to AD plus BC. Okay. Yeah, I'm back. So let's move on to the next section in the handout. The trivial inequality states that the square of any real number is non-negative. So basically, that might mean x squared is greater than or equal to 0, or basically any other quantity squared is greater than or equal to 0. So it's called trivial because it's pretty simple, but it actually forms the basis for um, many other inequalities. So if we take a look at the first example, um, we have this equation x squared minus 6x plus 15 times 9 squared plus 12y plus 12 equals 48. And this might seem like a very messy equation, but we can take a few steps to make it seem more simple. So first, let's try completing the square on the factors. So if we do that for x, we get x minus 3 squared plus 6, and then 3y plus 2 squared plus 8 plus 48. Okay, so if you look back to the trivial inequality, the two squares we have here, they have to be greater than or equal to 0. So that means their minimum value would have to be 0. On the other hand, we also know that 6 times 8 equals 48. So that means that both of these values must be 0. Otherwise, the two factors would multiply to something that's greater than 48, and we don't want that. So that means we can now solve the two equations. X minus 3 squared equals 0, and 3y plus 2 squared equals 0. And that means that the solution is x equals 3 and y equals negative 2 over 3. Okay, so that's one example. Okay, let's look at this one. So it asks us to show that x squared plus y squared plus z squared is greater than or equal to xy plus yz plus zx for all reals x, y, and z. So first thing we can do is bring everything to one side, and that means that we have something like this. So if you take a look at this, it probably seems really familiar to x minus y squared, or y minus z squared, and z minus x squared. Like these different expressions here probably seem very similar. So let's go along with that and take a look at these three trivial inequalities. Since all of these are squared and all of them have to be greater than or equal to 0. So if that's the case, then we can expand everything out. And then okay, now if we add everything up, then we get 2x squared plus 2y squared plus 2z squared, and also all of the x, y, yz's, and zx's. It's greater than 0. And if we divide by 2 and move the cross product terms to the other side, this gives us x squared plus y squared plus z squared is greater than xy plus yz plus zx. Okay. So we've shown that the statement is true. All right, so let's look at this checkpoint and talk about it in a few minutes. Talk about it in 1 minute, I mean. Okay, it's been 1 minute. Richard said that 5x squared and 5y squared must be non-negative. Um, but yeah, we already know that's true because x squared and y squared are always non-negative. Um, but for this one, we can first take a look at the 2xy, and there's an x squared and y squared here, so we can try writing that part as x squared plus y squared. And this is obviously a trivial inequality, so this is greater than 0. And then we also have a 4x squared left, which is greater than 0, and also 4y squared that's left, and that's also greater than 0. So if we add everything up, then it's 5x squared plus 2xy plus 5y squared is greater than or equal to 0. Now, any questions about the trivial inequality? All right, let's move on to AMGM. Okay, so the AMGM inequality is a um, very powerful inequality that basically says that the arithmetic mean and the geometric mean is greater than the geometric mean. So we'll first take a look at the case with only two variables. So as you can see, a plus b over 2 is the arithmetic mean, and the square root of ab is the geometric mean. So in order to prove this, we can take a look at the trivial inequality once again. So we know that a minus b squared is greater than or equal to 0. And if we expand this part, we get a squared plus 2ab plus b squared. Okay, wait, sorry. That might have been me, sorry. Okay, it should be good now. Okay, sorry about that. Right, so we have, if we expand it out, we have the greater than equal to 0 here. Oh, and this is supposed to be a minus sign, sorry. Okay, and then yeah, a squared plus b squared is greater than equal to 2ab. Okay, and then we can keep going. We can add another 2ab to both sides. It's greater than 4ab. And now this factors as, sorry, I did not use plan out my space very well. This will continue here. A plus b squared is greater than 4ab. So if we take the square root of both sides, that's a plus b is greater than equal to 2 root ab, and a plus b over 2 is greater than root ab. So we can prove the two variable form in this way. Okay, so in general, the formula will be the mean of the n numbers. And then to find the geometric mean, it's just the nth root of the product of the numbers. And the equality happens when all of the numbers are equal and greater than equal to 0. So like we saw in the second, in the two variable form, that we started with a minus b squared is greater than equal to 0. And this is only equal to 0 when a minus b equals 0, or in other words, a equals b. So equality will only happen when all the variables are the same. And the proof of this will, we're not going to show it today, but if you're interested, you can try for yourself or look it up online. Okay, so let's look at an application of AMGN. So for the minimum value of x plus 1 over x, find what it is and prove it. So because of AMGN, let's let x and 1 over x be our two variables. So plugging them into AMGN, which was this, that gives us x plus 1 over x over 2 is greater than equal to 1. And that means x plus 1 over x is greater than equal to 2. So the minimum value will be 2. And we know that equality happens when x equals 1 over x. And the only spot where that is true is x equals to 1. And yeah, if we plug in 1, we can see that it works. So let's take a look at this checkpoint. And we'll talk about it in a minute. Oh, sorry. Okay. Did anyone get an answer? Okay. I'll try to speed up a little bit since there's still a lot to go through before the Kahoot. Right. So we can let 4x and 9 over x be our two variables, and using AMGN, that means that their sum divided by 2 is equal to 4x times 9 over x. And in other words, that is 2 times 6, or 12. So the minimum value is 12. And that value happens when they are equal. So when 4x is equal to 9 over x, and that occurs if 4x squared equals 9, or x equals 3 over 2. Okay. We can use AMGN in more, I guess, unusual circumstances. So we have this rational expression, and we're trying to find the minimum value of this. And This looks pretty difficult, but we can simplify it to make it easier. So we see that there's a x plus 2 in the denominator. If we can find an x plus 2 in the numerator as well, it would make it a lot simpler to um, solve. So first, let's complete the square and of the numerator, and that gives us uh, okay. So if we complete the square, we get 9 times x plus 2 squared plus 16, and the entire expression is now this. Okay, now we can split the fraction into um, two parts. So one part will be 3/4 x plus 2, and the other part is the part with the 16, and that will be 4/3 and x plus 2 on the denominator. Okay, so now using AMGM, um, so the sum, each value, part of the sum is one variable, and we multiply them together. So um, on the right-hand side, we have the square root of the x plus 2's cancel, and we're left with just 1. So the minimum value of this would just be 2. And we have to check whether this holds. Uh, so that occurs when we have equality. So when x plus 2 equals to okay, we ran out of space on this page. But let's just move on to the checkpoint. So let's take a look at the checkpoint for a minute and then uh, discuss. Okay. Did anyone get an answer? It's 1. Okay. 29 over 10. Maybe not. So before we do AMGM, like you might be tempted to use x plus 1 over x and 1 over x plus 1 over x as variables. But notice that if that were true, then we would have to have equality, and that would mean that x plus 1 over x equals 1, which does not have any um, real solutions for x is greater than or equal to 0. Instead, we already showed before that x plus 1 over x is greater than or equal to 2 in the previous example. And then since, in general, if we look at the function fx equals 1 over x plus 1 over x, for x is greater than 0, fx is always increasing, since as x increases, the function increases. So that means we can look at this part here and say that the minimum value will be 1/2, because when x increases, this will only increase as well. So overall, the minimum value of this will be 2 plus 1/2. All right, let's talk about the Cauchy-Schwarz inequality real quick. And we might have to skip some of the examples so we can start the Kahoot on time. So this doesn't show up that frequently in competition math, but it's still very useful. So basically, we have two lists of numbers basically, A and B. So like A1, B1, A2, B2, and AN, all the way to AN and BN. So if we multiply A1 and B1 and add it to A2, B2, and find the sum of all the pairs and square it, it's less than squaring each A, multiplying by the square of each B. So the way we use this, oh yeah, and we get equality when the two lists of numbers are proportional, or in other words, there's some t that if you multiply b by, then we get a. So the way in which we can use this is in problems like this. So notice how we have x squared plus y squared plus z squared equals 1. And 3x, we're trying to find the maximum value of 3x plus 4y plus 12z. So we can set up the two lists of variables. Let's let the a's be the coefficients of this. So a equals 3, a1 equals 3, a2 equals 4, and a3 equals 12. And then for b's, we can let them be x, y, and z. So b1 equals x, b2 equals y, and b3 equals z. So the stuff on the right-hand side, a1, b1, that will be what we're trying to find. 3x plus 4y plus 12z squared. And that's less than or equal to the a squared plus times the b squareds. So that would be 3 squared plus 4 squared plus 12 squared times x squared plus y squared plus z squared. However, we know that this is true, so we can get rid of this because it equals to 1. Now we're left with just this, which equals to 169. And if we take the square root of both sides, we get that 3x plus 4y plus 12z equals is less than or equal to 13. So we have to see that the equality is true. So we have to show that 3 over x equals 4 over y equals 12 over z. But if we write everything in terms of x and plug it into this equation here, we see that it works. So that means that the maximum value of it will be 13. Let's see, how much time do we have? Let's take a look at, okay, now let's take a look at this example. Or do you guys want to try a checkpoint actually? What do you guys think? Okay. Okay, let's actually take a look at this checkpoint, since I think it's another good example. So, do you guys want to take a look at it real quick for maybe about a minute? And this should use the same principle that we used to solve the previous example. All right, did anyone get anything? Okay. If not, so again, we need 2 lists of variables. So let's let A and B be on one, and cosine theta and sine theta be the other. So the left-hand side will be A cosine theta then plus B sine theta squared is less than or equal to A squared plus B squared times cosine squared theta plus sine squared theta. And it's okay if you haven't learned this yet, but this is a trig identity and it equals to 1. So in that case, you can cancel this thing out. And it just wants the maximum value in terms of A and B. So we can take the square root of both sides. And we end up with this is less than or equal to root A squared plus B squared. Okay, and then let's cover one last thing before the break. Not all inequalities are algebraic. There are also geometric inequalities. So the most important one is the triangle inequality, and it's fairly intuitive to grasp. So basically, for any triangle, any of the side lengths has to be less than the sum of the other two. So for example, if you have A, B, and C, C has to be less than B plus A. And this makes sense because if you have a side that's longer than the other two, then you can't make a triangle because the side lengths don't match up. And we can prove this using, actually, we won't go over the proof in this meeting just for the sake of time. Let's take a look at this example. So we're trying to find the smallest possible value and largest possible value of x if a triangle with sides 5, 7, and x exist. So we have a few inequalities that result from this. First, 5 plus 7 is greater than x. 5 plus x is greater than 7. And finally, 7 plus x is greater than 5. This one is not that interesting because x is greater than or equal to 12, and that's we already knew that basically. This one tells us that x has to be greater than 2, and this one says that x has to be less than 12. So the largest possible integer would have to be less than 12, and that's 11. And the smallest possible integer has to be more than 2, which is 3. So their sum is 14. And this also extends to polygons. So in any polygon, any side length is less than the sum of the other sides. And this makes sense intuitively if you, the same way that the triangle inequality makes sense. And yeah. And the final theorem we want to cover is the Pythagorean. It's like an extension of the Pythagorean theorem. But we extend it to triangles that are not just right triangles. So first we have this, a squared plus b squared equals c squared. If that is true, then the triangle has to be right. However, if a squared plus b squared is less than c squared, then the triangle is obtuse. And keep in mind that we're assuming that a is less than or equal to b, which is less than or equal to c. And if a squared plus b squared is more than c squared, then the triangle has to be acute. Okay. So now let's take a about 5-minute break, and when we come back, we'll start the Kahoot. And you can also take a look at this problem right now during the break if you don't want to. Okay, so we'll be back at 3:05. Okay, you guys can join. Can you guys hear the music? We're waiting on people. Yeah, is anyone else gonna join? Yeah, 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, we're starting. Oh, okay. The answer was 3. So to solve this, you really only have to focus on the 5/8 part. Um, since we're trying to find the largest integral value, and then if you multiply everything by 5, then you get x is less than 25/8, and that's 25/8 is 3 plus 1/8, so it would be 3. Congrats to Moo. Interesting. So for this one, oh, it says the minimum number of shirts for which a customer starts to save money by. So when a customer buys 10 shirts, that's when they break even since both cost 140, but they only start saving money when they get to 11. So yeah, always try to be careful. And Jesse moves to first place. Hey, good job. Everyone got it. Jesse is still number one. Here's a hint. Try using AMGM. So I think there's a few people not in the Kahoot. If you still want to play, the game is at the bottom. You can also join. So this is a AMGM problem. The three variables we're using is the three fractions and the sum. Oh, did anyone actually use AMGM to solve it? So you have this thing on the left hand side equals the cube root of their product, but their product is just 1. And then you bring the 3 over, and the minimum value is just 3. Okay, maybe the next one will be better. Nice. Shion Yorigami. Still on top. Nice. It's like nothing changed. Okay. It's 32 times 33. If anyone's curious. Still no change. This is another AMGM problem, by the way. All right, so the minimum value is 4. Um, so we have the arithmetic mean on the left side of AMGM, and then the geometric mean on the other side. So the arithmetic, notice that if it's arithmetic series with 3 terms, um, the mean of the numbers is just going to be the middle number, which is b. So b would be greater than or equal to the cube root of 64, which is 4. So that's how we can solve it with AMGM. And then mu moves to the top. This one is also AMGM. Okay. Did anyone solve it with AMGM, or did you guys have any other solution methods? So I guess what we had is x cubed plus y cubed plus, oh, sorry, 2y cubed plus 4z cubed. The mean of this is greater than root, the cube root of their product. Sorry, this is really messy. But anyway, since it's a cube root and everything is cubed, this is just 2xyz. And then we divide the xyz and bring it to this side. And then we multiply both sides by 3 and bring that over to the right side. So now that's just greater than or equal to 6. So the answer is 6. Any questions about this? Great. Shion Yorigami retakes the lead. This one is a Cauchy-Schwarz Inequality problem. Okay, nice. Did anyone solve it using Cauchy-Schwarz? I'll go over it real quickly. But basically, let's let A, 2B be one list, and then 2A and 1 over B be the other list. So we can have this A plus 2B times 2 over A plus 1 over B. And that will be greater than or equal to if these are all square, let's all say that these are squares. In that case, it's root A times root 2 over root A. And root 2 times root B over root B squared. So that means, first off, this equals to 1, so we cancel it out. This side is root 2 plus root 2 squared, which is equal to 8. And we're left with just this thing is greater than or equal to 8. So that's the minimum value. Any questions? Okay. Five more questions left. Okay. This was also a Cauchy-Schwarz problem. Did anyone solve it with that? Okay. Well, it's pretty similar to the last one where we multiply the two together, and that gives you 2/5. Richard got scammed twice. Okay, great to hear. No change within the top two. Okay, 4 people got it right. Nice. Um, well, we want to make it less than 1, and then 100 to the 4th power is equal to the 100 million. So we have to make x bigger, and then it's just 101. Shion Yorigami is still on top. No, this is not a trick question. There are 2 values that work. 1 and 2. Yeah. Okay, last 2 questions. Hey, nice. This is AMGM again. Do you guys use that? Well, equality is achieved when the 2 terms are equal, and that happens when n is 6. So that's the answer. All right, last question. Well, this is a Cauchy-Schwarz problem. I guess we better go over it real quick.
I don't think it's a Cauchy-Schwarz problem because it asks for the maximum value.
Oh, maximum weight.
So for that, you would just need to try extreme cases.
Oh wait, sorry, yeah. For this one, the important part is that A, B, C, and D are all let me annotate, are all non-negative real numbers. And that means they're not negative. So the most that one of these can be is 1. If any of these are less than 1, if something's less than 1 and we square it, then it actually becomes smaller. So if we want to maximize this, we just let 1 be the value of one of the variables, and then the maximum value is 1. Okay. So, all right. Congratulations. Okay. That's all for this week's meeting. Thank you all for coming. Let us know if you have any like feedback or suggestions for the games, and also register for the Iowa City math tournament. We sent out an email this week with more information on how to register, but we'll send out another reminder after this week's meeting. And also remember to submit exercises to the leaderboard. Thank you all for coming. Oh, and you do not have to be in Iowa to participate. It's open to all the Math Circle members. Okay, you're free to leave unless you have any questions. You can stick around if you want. Okay. Bye everyone. Have a good week.
You too.